All right, so let's go through some of the questions that were on the most recent paper that we wrote. So this particular one, hopefully you did not add all of them. And if you did, that's okay. But what you hopefully realized was that from -5 to +5, those all match up and create 0 pairs. So the sum of all the numbers from -5 to +5 are 0. So that means all you're left with is -6 plus -7, which is -13. So hopefully you did not spend very long on that particular question. This one here, a lot of language written in this part. This symbol here means angle. So angle BOD means the angle that is formed from B to O to D. This means the measurement of angle COD. And then this is a line symbolism, and these are symbolisms for the symbolism for rays. So I think some of you are a bit confused on that. This means that they are congruent, which means that they are equal. So what you needed to see here was that from B to O to D, so right here, that was 90 degrees, which means if this part here is 32, then this part must be 90 minus 32, or 58. Likewise, from C to O to E, it's the exact same situation, but on the other side. So this angle here is also going to be 58. And then you've got this and this, which will be the same. So really, we've got our two x's, x, plus our 58, plus our 32, plus our 58. And it says that they're on a straight line, which means they add up to 180. So when you add those up, you do 180 minus, that's 90 minus 58, you will end up with, I think, 32. And then when you divide that by 2, you get 16. So the missing angle is 16. Okay, so let's look at this one here. So a lot of you got this one wrong, but you were actually super close and you had the second best answer. And unfortunately, it wasn't the best answer, and so you got it wrong. So most of you realize that to create the greatest value you can, you want to put the biggest thing here, and you want to put the smallest thing here, right? So what's the biggest thing we can possibly do here? 765. What's the smallest thing we can do here? And a lot of you were thinking really well, which is good. You were thinking about the fact that, wait a minute, I could put negative numbers here. And if I subtract a negative number, that's going to help me get the biggest value possible. So you were thinking in terms of, what if I have 1, 2, 3, 4 left, then 1, 2 minus 4, 3, that's going to give me negative 31, which then when I put those together, when I subtract negative 31, it's like adding, you get 796. And that was really, really great thinking. Unfortunately, a couple of you were able to realize, hey, wait a minute, if I do 12 minus 53, I'm going to get negative 41. And all I really need to do here, instead of doing 765, I could just do 764, which is only one different, right? 765 versus 764. We're only off by 1, but we made 10 difference here. So if you did that, 764 minus negative 41, you're actually going to end up with 805, which is the biggest. So most, or a lot of you got this wrong because you wrote 796, which was such a close answer and it was the correct way of thinking. You just sort of had to realize that a difference of 10 here or a difference of 1 here was worth it. All right, so this one, excuse me, pretty complicated to think through. One of the easiest ways I think to think it through is to be replacing the equation here with letters. So for example, we know that A is going to be 1900 and we know that B is going to be 79. So what you could do is put A plus B cubed minus A cubed minus B cubed will be A times B times A plus B. So again, let me just go through that. Everywhere I see a 1900, I'm going to replace it with an A. And everywhere I see a 79, I'm going to replace it with a B. So 1900, a 79, a 1900, 79. Down here, 1900, I write an A. I could write the time symbol, but remember when we introduce letters, then it looks like an X, and it's better to try to just use brackets or write things. Remember in math, when things are written beside each other, it means multiply. So this means A times B times A plus B. So now what I can do is this tells me right here what A plus B cubed is. So I can replace this part here. So this part right here, I can replace with A cubed plus 3A squared B plus 3AB squared plus B cubed. Anybody that's interested, this is trinomial expansion. And if you want to look it up, look at it in relation to Pascal's triangle. So Pascal's triangle that looks like this. What you're going to notice here is, see this 1A 3 3 1. That's this line on Pascal's triangle. And this is where you've got cubing things. This is for squaring things. The next line would be if you were putting it to the exponent of 4. So look it up if you're interested. So if this said A plus B to the 4, we can use Pascal's triangle to help us. If it said A plus B to the 2, we can use Pascal's triangle, etc. Anyhow, that's just an aside for anybody that's interested. So I'm replacing that whole thing with this, and then I'm taking away my A cubed and I'm taking away my B cubed, and then my bottom stays the same, AB times A plus B. So now the interesting thing is that's going to cancel with that, and that's going to cancel with that, and I'm going to be left with just this part here. Now this is where it gets a bit tricky for some of you. What you need to use is something called factoring, which most of you wouldn't have learned because you don't really learn factoring until a little bit maybe in grade 9, mostly grade 10. What we're going to do here is we're going to look at what's in common between these two. Well, they both have a 3 in common. What else is in common? Well, this has an A squared and this has an A. So they both have one A in common. And then this is a B and this is a B squared. So they both have one B in common. Then what would I need to multiply 3AB by to get a result of 3A squared B? Well, what I'm missing there is I need another A. Likewise, if I have 3AB and I want 3AB squared, I need another B. That's called common factoring. And I can divide it by what was always on my denominator. Now you're going to see, hey, wait, I can cancel because it's all multiplying now. And I can cancel and I can cancel, and I'm left with 3. So, excuse me. That's, I think, the least complicated way of doing that question. That is a very difficult question if you're not so great with your algebra. So grade 7s, I mean, really, you're not going to be so great with your algebra because you're just learning algebra. And also if you've never been exposed to factoring before. So this one here, there's a couple of different ways to approach it. I really honestly think the best way to tackle this one is to be trying something like a guess and check, where you're looking at, okay, let's look at two numbers like 1 and 13, or 2 and 14, or 3 and 15, etc., or 4 and 16. So here you're going to be like, what's the greatest common factor here? That's going to be a 1. Or what's the greatest common factor here? That's going to be a 2. What's the greatest common factor here? That's going to be a 3. That's going to be a 4, and so on. What you're going to notice if you keep doing that, so now you might think, oh, well, there's a pattern, 1, 2, 3, 4, but no, when I try 5 and 17, the greatest common factor is 1. Well, I've already used 1, right? When I try 6 and 18, for example, in this case, yes, the greatest common factor is 6. Then if I tried 7 and 19, I'd get 1 again. 8 and 20. So here I'm actually going to get 4 again. And if you kind of keep going through, what you're actually going to find is that you're going to get the numbers 1, 2, 3, 4. 1, 2, 3, 4, 6, and then, which I've got 1, 2, 3, 4, 6 here, and then the last one is 12. Because, for example, 12 and 24. Okay. Once you kind of give that a try, you're going to actually find or realize that there are no other greatest common factors, that those are the only greatest common factors. The other ones just repeat. So the number of possible values, there are 6 possible values here. And it's all based on 12 as the factors of 12, basically, in this case.